Hello, let's go through some force problems. Determine the tension in each cable below. Draw a force diagram for the system before solving the problem. Okay, so we always, and the point in this, well, it's a few points, but when we draw our force diagram, I like to identify the system. This will help me identify the tension in the cable by using the ball as the system. So the downwards force on the ball is gravity on ball by earth. The upwards force is tension on ball by cable. These are the same because the ball's just hanging there. All right, and it's asked to work out this tension force. The cool thing is, I don't know how to do that, but I know that my tension force is equal to my gravity force because they are equal and opposite. Can I work out my gravity force? Yes, I can, because I know this is 5 kgs, and the force of gravity is 9.8 newtons for every kilogram. So I multiply those together. Got my calculator here because I can't do it in my head. 49 newtons. Great. Case B, cable suspended by 2 cables. Okay. Identify the system. Draw a force diagram. The downwards force is the force of gravity on ball by earth. There's two things interacting. Remember, a force is an interaction. What's interacting with this ball? There's 2 cables interacting. You could draw it like this. Force tension on ball by cable 2, and this is force tension on ball by cable 1. Or you could draw it like this. And together, that is the same size as that. Because it's not moving. Its net force is 0. It's not accelerating. So let's go through this process again. We know the force of gravity is the same size as last time, is 9.8 newtons per kg times 5 kgs. That is 49 newtons. We know that's equal to the combined of both cables. So each cable must be 49 newtons divided by 2, which is 24.5 newtons. Determine the tension in each cable. Oh, tough. Okay. What we're going to do is it turns out cable B is the easiest first. So the same process of identifying a system, let's identify this ball. So force of gravity on the 4 kg by the earth. What's interacting, pulling it up? Cable B. Force of tension on 4 kg by cable B. They are the same size. So force of tension is equal to the force of gravity, which is equal to 4 kgs times 9.8 newtons per kg. And if I do that, I get 39.4 newtons. So this is the tension force in B. Let's now do A, which is actually quite hard. Let's identify the system. This makes life so much easier because then I can see the things that are going in and out of the box. The 5 kg has gravity pulling it down on 5 kg by earth. it also has a cable pulling it down. F tension on 5 kg by B. Then it has a cable pulling it up. Now, how big is this? Well, I think you can see once we've got our force diagram, it has to be as big as both of these put together. F tension on the 5 kg by cable A. So cable A has to be the same size as both of these put together. We know what the tension force of cable B is. We've worked out cable B's tension force. That's equal to 39.4 newtons. We can work out the gravity force on the 5 kg by the Earth because that's equal to 5 kg times 9.8 newtons per kg, and that equals, we've worked something like that before, 49 newtons. So if I add both of these together, it's going to give me this one. 49 newtons plus 39.4 newtons, and that equals 88.4. Good. And it tells us here, answer check, cable A is 88 newtons to 2SF. I'm going to talk about that 2SF. SF means significant figures. Next lesson. So for now, let's just say 88, 88.4, basically the same answer. When you get on to next lesson, I want to make a short 3 or 4 minute video explaining what significant figures are. I just to last point out, if you'd asked me to work out what the force is in cable A, I wouldn't have been able to do it with without all these diagrams. Okay, so don't skip on the diagrams. If I need to use them to make it logically make sense and I can figure out what's going on, then you should be using them too. Okay, diagrams are helpful. Identifying the system, so helpful as well. Great.